screen. Yeah, if you're seeing my screen. So the first, the instructor gave you an example, and we'll just do kind of one like this. Let's say that I want you to find the area from -1 to 2 of x squared plus 3 dx. And this is the Fundamental Theorem of Calculus part 2. You just have to, we did this a little bit yesterday. The main thing you're doing here, excuse me, is you're finding the antiderivative, the integral x to the n dx equals x to the n plus 1 over n plus 1. So we're going to do a lot of these today, and like we're going to get really comfortable with this so that when you see it on a test or quiz, you're going to be able to knock it out of the park. All right, so if you're still with me, this
so x to the third over 3.
Right, this is really x to the 0, even though it's not written, and you don't really want to write that, but you can for this. It's going to be
plus 3x,
and you're going to evaluate from -1 to 2.
Okay.
Again, so the Fundamental Theorem of Calculus part 2 is top minus bottom, essentially.
Right, so that's 2 cubed over 3 plus 3 times 2 minus -1 cubed over 3 plus 3 times -1. So then that's 8/3 plus 6 minus
this is -1/3, so it depends if you want
plus 1/3 then.
Yeah, and then this one is -3,
minus
but then
3 plus 3.
Yeah, so you have 9/3 here,
plus 9,
which is 3 plus 9, so you get 12.
9. Oh yeah, because 9 divided by, yeah.
Okay, so that's kind of a nice example. Then we move to, do you want one like this, or do you want me to just move on to another example?
Maybe one more like it.
Okay, so let's go integral -2 to 2 x cubed plus 1/2 x dx.
Okay, so then it's x fourth over 4 plus x root x, right?
It's power of 1 here, so we're going to continue to use this. Whatever this is, it becomes, you add 1 and you divide by the new exponent. This 1/2 out in front is just a distraction. It just goes with it.
Oh, okay, so it's 1/2 x squared over 2. Yeah.
Yes.
Right, and then that's from 2 to 2. So then it's 2 to the 4th over 4 plus 1/2.
So you can always combine like 1/2 them over 2 and make it over 4. Like you can do 2 squared over 4 if you want.
Okay. -2 to the 4th over 4. 2, and then that is 2 to the 4th. 2 times 2, 8 times 2, 16 over 4. So that's 4 plus 4 over 2 is 2 times 1/2, 1 minus 16 over 4. Or no, just 16 over 4, so -4 plus 1 0.
Yep.
Okay.
So in short, in summary, like the Fundamental Theorem of Calculus says, do it and then evaluate at the endpoints. And then we just need to do more examples to like get comfortable with the possible things your instructor could throw at you.
Okay.
So if you're ready, I'd like to give you a few more.
Yes.
So the first one, we'll just kind of be kind here. We'll say x to the 1/3 minus x to the 1/2 from 0 to 1 dx.
Okay.
Yeah, let's just, we'll go with that one.
So you just do, okay, so it's,
So you got to add 1 to each of the exponents, and it's fractions, so it's uncomfortable. It's
1/3 plus 1, so then it becomes 1/3 plus 3/3, so 4/3.
very good.
Okay, so it's x
But then you
4
divide
thirds over, yeah,
or 4/3.
minus x to the 3/2 evaluated at 0, 1. So
I would flip the bottom one first before you go much further here. Like I would make this 3/4 x to the 4/3 minus 2/3 x to the 3/2. Just because it'll be easier than trying to deal with it later.
you just multiplied, okay, by the reciprocal.
Yeah.
4, 6.
Okay, so now you evaluate at the endpoints.
So you don't really have to worry about the 0 because that's not gonna
right
do anything. So it's just,
and anything 1 to any power is always 1.
so it's just 3/4 minus 2/3.
Yes.
So that would be times 4. 9 over 12 minus 8 over 12, 1/12. Right?
Let's see. Yeah, so 9. Yep, 1/12. All right, so another one here, if that's okay.
Yep.
So this will be the 4th root of x to the 3rd minus the square root of x from -1 to 0. So I can do, there's a lot of things that can be done to make this like, oh, actually, I'm sorry, I got, yeah, from -1. So that, that you have to be able to change these to power rule to the exponents, and then the, actually these limits are okay. I meant to flip these. So let me do it the other way, from 0 to -1. Nope, that won't work. Sorry, I'm being silly here. Let's do 1 to 0. That'll work just fine. All right, so give that a try.
Wait, I thought always like the smaller number had to go on the bottom.
It does. So if you want to make it that way, and you can definitely do that, you can change this to negative out in front, which flips the order of this.
Okay.
And that's totally up to you if you want to do that. Like if you wanted, like this is the way I would do it. If like once you get more comfortable, I would say, okay, that changes the order here to square root of x minus the 4th root of x cubed.
Oh, so it just flips it. Okay.
Yeah, and then you might even write, okay, it's -1/2 x.
But what's the advantage of doing that, of flipping it?
Just to not have to deal with the negative out in front. You want to incorporate as many algebra steps as you can before you do your calculus.
Why would you have to do a negative out in front?
When you flip the order of the limits of integration, you have to put a negative out in front. We were looking at this. If it's the integral from a to b f of x.
You can't just solve this with the 1 to 0 integral. You have to flip it.
No, you can do it. You can do it as it is on the left, or you can flip it to the right. They're the same.
So if you flip it, you don't have to put a negative out front?
No, if when you flip it, you do have to put a negative out in front, but the negative on the has been included over here on the right. So like there's an intermediate step here. The intermediate step is negative integral 0 to 1 4th root of x cubed minus the square root of x dx. And then you distribute that negative to both of these. So this one is negative. The 4th root of x cubed is negative, and the square root of x is positive.
Why don't you leave it in the order that it's in though? Why do you move the 4th root like second?
So the more math you take, the more like this stuff matters, where you actually want to make it look pretty as you go to make it easier to like evaluate and like work through.
Oh, okay.
It's like lining up books on a shelf. Like you start naturally doing it all the time. It's not necessary, but it's like a important thing to do. If you do it on the left here, the way it is on the left, which is fine also. That's why I wanted to show you this problem, because there's like 3 ways to do it and they're all correct. They all give you the same answer if you work through the steps correctly. So you should do this the way you want to do it. Like if you want to do it on the left here, that's fine. If you want to put the negative out in front, that's fine. If you want to distribute the negative, so the first one is negative and the second one is positive, that's fine too. You've got to be comfortable with this.
How do you do the antiderivative though?
You got to write them as powers.
Okay.
And that's why I chose this problem, because there's these exponent rules you have to remember.
Yeah, so then it's 3/4 plus 1.
Which one are you doing, so I can do the work with you to help?
Which one am I doing? I will do the third one with the yes.
Okay, great.
Okay, at 1 and 0. So then it's minus 0. How'd you get 2/3 and the 4/7?
So you have to add 1 to 1/2 to get 3 halves. Do you follow that?
Yeah.
And then you divide by the same exponent.
Yeah.
But when you bring it up, you flip the fraction. You flip whatever's in the bottom to become 2/3.
Oh, right. You have to do okay. So
Reciprocal. Yeah.
it becomes 2/3 x to the 3 halves, and then you put the 1 in there. But so then when you put the 1 in, the x.
Yeah. So 1 to any power is 1 is just 1, but then you multiply by 2/3.
Oh, so then it's okay, 2/3, and then it's minus. So it's 2/3 minus 4/7. And that's 7, that's 3. 14 minus 12. 2/21.
Yes. All right, are you ready for more of these?
Sure.
Okay. So let's go integral 0 to 1. That's a pretty common one. X to the 1.5 power minus 1 over x squared. So this has a couple of maybe new things in it. So the first one is that it's a decimal, and you just do the same thing. You can convert it to a fraction if you want. At some point you will, but you might see something like that on your quiz test. So you could write this. You could say it's 2.5 over 2.5, but then you got to for sure.
2.5.
Yes, because you add 1 to the exponent.
Oh, you're doing the antiderivative now.
Yes.
Okay.
Yes. And actually, I gave you a bad one here. Sorry, let's not do that one. Let's do x to the 0.7 power.
Okay.
So you get x to the 1.7 over 1.7.
So do you do the same thing where you like bring the 2.5 up?
You can't, no, you have to convert this to a fraction. So this is 5 halves. So it becomes 2/5.
So it's 2/5 x to the 2/5.
2 or 5 halves if you wanted to,
Oh,
but you could leave it 2.5. That's okay.
okay.
1.7 is 17 over 10.
It's difficult. Okay.
So it's 10 over 17, x to the 1.7, evaluated from 0 to 1.
Okay, so it's 10. And then, so it's 2/5.
So to get you
Oh,
get
it's 2/5 minus 10/17, basically.
yeah, and we'll skip the combining of that because I just made some bad numbers in there. Okay, let's do some negative exponents because you're going to see that for sure. What is the integral from 1 to 2, 1 over x squared plus 1 over x cubed dx?
Okay, so
There's almost always a rewrite step, which helps you to do this. You know, this is x to the -2 plus x to the -3.
okay, so then it becomes x to the -1 over
-1. Yep.
Okay. Plus x to the -2 over -2.
Mhm.
At 1 and
So this one may be worth, again, kind of there could be a rewrite that's worth doing here to make it easier to evaluate. It's the first one is negative because that -1 over x minus.
Like, can you do, oh, I guess you can't do a negative exponent though. That's
You're
why.
going to be uncomfortable doing that with, like, when you evaluate it, it's going to be frustrating. So that this -2 is here, and then x to the -2 comes down here, and you evaluate that from 1 to 2.
So you just flipped the -1 over x. Okay. -2 squared. So then it's -2 or -1 over 2. It's 2 over 1 squared.
Yes, this one's a little bit harder to evaluate. It's, you know, -1/2 minus 2 over 4 minus.
Minus. 1 minus 2. So then that's 2 fourths minus 2 fourths. 1/2. Plus. So then 1/2 minus 1/2 is minus 3 plus 1. Doesn't it turn out to be 0?
It's going to be positive because of the way these curves work.
-1, I mean, -1/2 minus 1/2.
Right, that's -1.
Oh, wait, that's okay. Never mind. So then that's -1 plus 1, 0 plus 2. Oh, yeah, 2.
Yes.
Okay.
Okay, so like I'm gonna guess that, like, you know, once you get the hang of this, like this isn't too bad, but there is some like fractions and stuff that you got to get faster at, just nature of this, like you haven't done it in a while.
Yeah.
So let me throw some things you might see. Let's go from 1 to 2 again. Actually go 1 to 4. Square root of x minus 1 over x squared dx.
Okay.
This has got another kind of little thing to it it's just uncomfortable because of all the fractions and the roots and the exponents, but that's the test questions. I mean, these are what you'll see on there. So like I would rewrite it like this before I did anything.
Okay, so
So then you got to add 1
minus x the negative, 1 over -1.
and so these are going to combine, which is going to help here. So that, you know, and I would at some point you want to rewrite like the fractions and this. So I would do it here. I would go 2/3 x to the 3/2 plus 1 over x
Plus 1 over x. Okay, so that's 2/3 minus 4 to the 3/2 plus 1 over 4 minus 2/3. Well, that just becomes 2/3 plus 1, basically.
So it's 2/3 4 to the 3/2 power plus 1/4.
Yes, minus 2/3 plus 1.
Yes. So this one is the one that might be, you know, a little bit weird.
Yeah.
So if you recall, 4 is like 2 squared. And then to the 3/2 power, you multiply these, the
Right.
exponents.
Okay.
So it's 2 cubed, which is 8. Right, 2 over 1.
You did 2 times 3.
Yeah, 2 over 1 times 3/2 gets you to 2/3, 2 to the 3rd, which is.
But you just did it like 6 over 2. Yeah, okay. So 3, 8. So then it's 2/3.
2/3 of 8, which is 16/3.
Oh God, okay.
I'm sorry, you might see this. Minus 2/3.
Yeah, minus 1.
So
So
like,
then
this gives you 14/3.
14/3 plus
This,
1/4 minus 1. So then these multiply. So that's 4, 3. Oh, okay. So
so you get, was that 56? So you get 45 over, no, 47 over 12.
let me make sure I get the same thing. Yes, I got 47 over 12.
Okay. We've really done a lot of these. We could spend the whole lesson doing these, but we probably should move on. If your goal is to get through 6.5.
Okay.
Also,
So that's everything for 6.4 pretty much.
it looks that way to me.
Okay.
I've covered all the
Sounds good.
examples and then some that I think,
Sounds good.
okay. So 6.5, your instructor, he gave you some problems here, which are hard to replicate, but I think we can do some of them. This problem number 59, do you have any others like this in your book that we can look at, or I can make one up
Those
too?
ones were technically part of 6.4, the first two slides on 6.5, because we didn't get through them.
Okay.
I don't know if those came. Oh, I don't have my textbook.
So the only thing, there's nothing we haven't covered is the FN int on your calculator. Are you comfortable with that?
That's just like the math 9. That
Yes.
thing where you
Yes.
plug in. Yeah, that's fine.
Okay. All right. So so that this problem 59 is that I see on, go ahead.
We can just do those problems too. Like again, if they're too hard to.
Yeah, they're tough to actually evaluate. But yeah, we can do that. I can make them up too, but it would be great if we could just redo them.
Yeah,
Here,
just
so.
redo them because I don't really honestly remember. So.
All right, so we got this, and they give you some given information here, which is great. This is given in every problem. They're saying h of x is the integral from 1 to x f of t dt. So they're going to give you a value of x. They're going to say like h of 1 in your first problem, and then you put 1 into the integral. And this right here is f of t, this graph, which I guess isn't said clearly, but part A is to find h of 1, which means put 1 in there. So integral 1 to 1 f of t dt. And you might be thinking, well, how can I do that? But because the limits are the same, this is 0. It doesn't matter whether it's 1 to 1, 8 to 8. If the limits are the same, it's always 0.
Okay.
All right. So the question B is a little odd. Let me, before we do question B, what is the integral from 0 to 1 f of t dt graphically? And do you agree that it's this area right here?
Yeah.
Okay. So B is a little weird. It says, is h of 0, greater than 0 or less than 0 or whatever. So it's the integral from 1 to 0 f of t dt. So there's a lot going on. The bounds are backwards. So like from our previous discussion, again, just to be clear, your 0 means to put 0 in for x up here in the top bound. So if we want to go from 0 to 1, we have to negate it.
Okay.
And I just asked this question. I said, hey, like, is f of t dt the area under the curve here? And you said yes. So that area, like, we don't know what it is, but it's a number. It's positive though, because it's above the x-axis. But if you negate it, it becomes negative.
All right.
So this whole thing is negative, and that's why it's less than 0.
Can you just like assume that if they ask you that, it's just like the opposite?
No, because what if I gave you a graph that looked like this? I said that, and then so that's 1. It's the same question. Now the area is negative.
Yeah, but you don't do the same flip thing.
Well, the flip thing just puts the negative out in front.
But that's what makes it that's what makes it a negative number.
Let's just reset here on. Let's call this 2 or a half. Half's probably more reasonable. So this f of t dt from 0 to 1 is 1/2, but then you bring the negative down.
Right.
Right. Okay. But if I asked you, if I gave you a function where it was down here, this area would be negative 1/2. And then you would negate it and get positive.
Yeah. So that's like, so if it's below the x-axis, it's going to be a positive one. And if it's above, it'll be a negative.
If the limits are correct. Or if their limits are in the correct order. So let's just talk about what you just said, because it's very important here, and I want it to be very, very clear here. So let's go A, B, C. So A, B, C. The integral from, and we'll call this f of t, the integral from A to B, f of t dt is greater than 0. The integral from B to C, f of t dt is less than 0.
Okay.
Now, what about, I'm going to go right here. What about the integral from B to A, f of t dt? So it's talking about this region.
That's when you have to flip, because like,
yes,
it should be smaller to bigger.
Yes.
So can you go up to the problem again?
Yeah, let me just do this last one here.
Okay.
So if I flip this and I go from C to B, f of t dt, it's greater than 0. Like, because the area is negative, but then because the bounds are wrong, you have to flip it. So
right. So what were the bounds on the one that we just?
They were backwards. They're backwards.
I see.
So if they're in ascending order, it's positive above, negative below. If they're in the other order, everything changes. Okay, I made this, that's all left justified. Okay. All right, I got to go back and grab the graphs again to restart this for the next part. Is that okay?
Yeah.
This here. Okay, and then C, it says find where there's a maximum. And this is super confusing, I think, because you're like, wait, I did maximums with derivatives, but it's saying like, because h of x is the area under the curve. Was it 1?
Mm-hmm.
That's 1 to x, right? F of t dt. Like, all of this means area under the curve. So
right.
this contributes positively. This area contributes positively, but the next area over contributes negatively. So you want to stop when you're done contributing positively. Like, you wouldn't want to take away any.
Okay.
So that's why you know to stop there.
Okay, so just any portion of the graph that's above.
Yeah, and
so what if it like goes back above though? Like,
so then you got to decide, well, how does this area impact this? Like is there more here than there is here to like make this better? Because let's say this is a half and this is like 5 and this is like -10 area.
Huh.
So like this might only be an area of 1, So it doesn't really counteract this very much. So you'd want to
But
stop here.
wouldn't it still be a maximum? Like, wouldn't?
No. It's not like a critical points anymore.
Oh, okay.
It's literally like where can you get the most contribution from the area?
Okay.
So and the reason it's a maximum is the integral from 0 to 1 f of t dt. That's this first one. It's some amount, which we don't know, but it's positive. And then the integral from 1 to 4 f of t dt, this next region, it's also positive. So these work together.
Okay.
Like they combine, whatever they are, they combine up. Great, we're happy.
That makes
Okay.
sense.
All right. Now part D, it's kind of the same thing, but
The minimum, right?
the minimum. So you're like, okay, well, when does it either like keep going negative, or when does it, like when you add it all up, does it keep going negative? So like again here, this is a positive area, this is a positive area, but then you've got this area below the axis, which is negative.
Yeah.
So all this in blue is negative, and it's gonna counteract this stuff. So this point here, if you integrate from 0 to 4, 5, 6, 7, 8, was it 1? I keep forgetting. Is it 1? I don't know. Yeah, 1 f of t dt. This counts negatively. So like your positives add together, but then this counteracts that, and this is going to be your minimum. But you have to say at x equals 8.
Why is it not? Wouldn't it be the point that that's like lowest on the graph though?
But remember, h of x is the integral now. It's not the function. It's not the curve. Like you're trying to apply the rules that we use for derivatives to an integral. They don't work.
So why is the integral only to 8? I mean, why is it to 8?
So h of x refers to area under the curve. Like h of 1 means the area from 0 to 1, or I guess it's 1 to 1. H of 4 means the area 1 to 4. And it does not refer to a point on the curve. That I think I don't know how to make that. You can just try it again, but this is not a function. It's the area. It's the integral. It's the area under the curve.
So, okay, I get that, but why is 8 the minimum? Like, I don't.
So if we could give these numbers, which I think will help. Let's say that's a half, and that's 5, and this down here is -10.
Yeah.
And then h of 4 is the 5. It's just this area. It's going from 1 to 4, so that's 5. But h of 8 is the area from 1 to 4, which is 5 minus the 10. So you're just looking at these two numbers and saying, well, which is smaller, which is bigger?
Why wouldn't h of 4 and like h of 4 also include the 1/2, and why wouldn't the h of 8 also include the 5 and the 1/2?
So I keep messing this up. It starts at 1. If you go back to the actual question here, it says it's from 1 to x. It's not from 0. I messed that up a few places, but it's the area. H of x is the integral from 1 to whatever x value you put in. So this
So the 1/2 doesn't matter.
Yeah, it's not even part of this.
Okay, so I see. Okay. Okay.
It has nothing to do with like where a point is on the curve. It has to do with like adding regions above as positive, regions below as negative.
Okay. It's kind of confusing, but I
Yeah.
sort of get it, I think.
Okay, like here's a related question that you might see. And let me try to like give you this and then make it more sense. This is like this. Okay, so this is we'll call this 2, -6, and 5. Those are the areas, and that's A, that's B, that's C, that's D. Okay,
Yeah.
so what is the integral from A to B? They'll call this f of t dt. What is that equal?
B to A.
A to B.
2.
Just 2. What is the integral from A to C, f of t dt?
-6 minus 2.
It's 2 minus 6 because you have to add, you contribute both areas.
Okay. Wait, so
Like
above when we did h of 8 did you subtract then?
so okay, let me just call this 6 then, and then like I was trying to make it clear that that's negative because below the x-axis, but the area of this is 6.
No, I know, but why on the problem above did you, when you did h of 8, you subtracted?
Because its area is 10, but it's below the x-axis, you negate it.
Oh, I see. Okay.
So this area is 6, but we're going to negate it, so that's -4. So right now, where's the max? That's the max is right here at B.
Wait, so it is 2 plus -6?
Yes.
Okay. What was your question? Sorry.
The question is like, which is the max? Is it at B or is it at C?
Me.
It's at B because it's positive, and
Yeah.
-4 is your min.
Min.
So let's keep going. Let's go from A to D, f of t dt.
So it's 2 plus 6 or
-6.
-6 plus 5.
Right, and that's 1.
Okay.
So is that where's the max and where's the min?
Same places as before.
Yes.
I see. Okay.
Let's say, I mean, I could add more, right? I could come down. I mean, this goes on and on and on, I guess. Okay.
That's much more clear.
All right, great. I want to do this classic exam question, but I also want to know if we need to do part E, because part E is like it's unrelated to what we've been doing. Actually, it's going back to derivatives and what you learned before your winter break.
I don't really remember what part E was.
I'm sorry, it's the inflection points. It's the inflection points.
That's just where it changes sign.
It's mins and maxes of the derivative. Because the graph we have here is actually the derivative, even though it doesn't say it is.
So yeah.
And that's really because this is y prime. I know it doesn't say that, but it's this, and it actually ends up being that. But
so the inflection points are 1, 3, and 6.
Yes. Yes. Okay, so here's this classic exam question is, what is the integral from we'll make this really not too bad. Go from 0 to 3, absolute value of 4 minus x squared dx.
Okay.
So 4 minus x squared, if you were to graph it, and we do need a graph here, is it looks like this. There's 4, it hits at 2, right? And then it keeps going. It goes down here, believe it or not. Like it goes down to, if you put, if you were to graph 4 minus x squared, this is down at -5, okay? But because it's absolute value, it flips it. So it actually comes up this. So it does this, but because it's absolute value, it comes back up like that.
Where did the 5 come from? The
Putting
negative
3
five?
in for x, 3 in for x, 4 minus 9.
Oh, I
gets
see.
4 minus 5.
Okay.
So what this becomes, it's really two integrals. It's the integral from 2 to 3, where you do this part,
Right.
and then the black is the other part. It's from 0 to 2, 4 minus x squared.
So you have to do that area. So then you do like, oh, is this where you do the trapezoid thing?
No, I'm just trying to show you graphically like what's going to happen. You're not going to get one this complicated, but you're gonna have to
Well, how do
find
you-
these zeros. Well, you have to change this. It's x squared minus 4. It's beyond where you're at in this course, but
Oh, but if you did the graph, you couldn't do the areas like from the graph.
no, you have to use antiderivatives.
Oh, okay.
So like that, and that's covered. The reason I bring that up is that was covered here in. Sorry, I'm looking. Maybe it was at the end. So it was the end of. Oh, your instructor used that with FN int. I don't know. So I would ask your instructor if you're going to see them. I would say, are you going to give me any problems?
Absolute value.
But not an absolute value function, like because you can do this. This is okay, but like integral absolute value of like something else, where this, like I said, is like x squared plus 1, or
So something more than just like X.
Yeah.
Okay.
Yeah. All right. Well, that takes us to the end of our lesson today. I guess I'll see you on Sunday.
Yes. So we can finish the rest of that with the trapezoids and stuff. I
Oh,
think
great.
the rest of.
Yeah.
Okay.
Cool. Well, thanks so much, and I'll see you next time.
Thank you.
Bye now.
Bye.